Okay, we're in the section on homework, and we're going to go through each problem separately. Certainly, there's work there. You could look at what work's providing to you, or if you need additional support by watching me do the problems, that's fine too. The intent then is to get you to do the problems on your own and successfully match the answers that we're providing to you. So I'm going to go to the whiteboard, and I'll do one problem at a time. Again, this may go quick for some students, and the reason for that is that maybe you haven't studied the material enough. Once you study the material, though, these problems should go relatively quickly. All right, relatively quickly. Like, there's how many problems here? I'm going to say, it looks like, oh, wow, that's a lot of problems, huh? 15 problems. I'm going to say, maybe 30 minutes if you're prepared to do the problem set. All right, if you're not prepared, a lifetime. All right. So let me go to the whiteboard. And I'm going to start doing the problems one at a time. And I'm thankful for an answer key because we can actually check the results of our answers just by looking at the answer key. My goal, though, is to do the problems without looking at the answer key until I'm finished. All right, so let's take a look. Problem number one, I'm kind of looking at it, and I want to take its derivative, and it's going to be dy dx. All right, this over here, this is problem number one. So dy dx, that's y prime. And what do I have over here? Well, the derivative of cosine, this is the outermost function, is going to be minus sine. And its argument is going to be 7x cubed. Then I go to the inside, take the derivative of 7x cubed, which is fairly simple, 21x squared. I would rewrite that as minus 21x squared sine 7x cubed. Put a box on that, get my red pen out, and see how we did. Let's see. This and this, we did good. Let's go to the next question. Next question will be problem number two now. All right, so what's number two? Oh, this looks like a very similar problem. Take its derivative, and they want the derivative of the function that follows with respect to x. And that's x to the fourth power. What do you get over here? Well, it's going to be a constant multiple of the sine's derivative, which is the cosine, x4, times the derivative of the inside, which is 4x cubed. We're using a chain rule. What's that going to be? 12x cubed cosine x4. Put a box on it, get my red pen out, and look at their answer and make sure I got the same answer. If I don't, I know I did something wrong somewhere. If you ever think there's a problem with the key, though, please bring it to my attention, and I'll certainly look at it. And certainly I'll fess up to any errors I make too. And yes, I do make errors. All right, this one over here, calculate the derivative. Wow, it really looks on the same problem. I want to communicate to a lot of students, though, that this gets a little bit confusing. And I'm going to put this right a little bit differently, that it's actually something being cubed. If this confuses you, you wouldn't write that down. What I'm going to do, I'm going to write down the derivative. It's the outermost function, it's a cube. So it's 3 times something being squared. What's that going to be? Sine 2x times the inside. Well, the inside outermost function is cosine of what? 2x times, well, the derivative of 2x would be 2. I want to clean it up a little tiny bit. This would be 6 sine squared 2x times cosine of 2x. I'll put a box in this. I'm going to look at the key and see if we got the same answer. And this is what I'm looking at. Look at the key, 6 sine squared. Yeah, I got the same answer, which is good news. All right, let's do the next one. And again, my goal here is to rewrite the problem so it's easier for me to do. All right, so I'm going to write this as, let's see, 36 t squared, excuse me, plus 9 raised to the 1/2 power. And what do they want? They want y prime. And what's y prime? It's actually dy dt. All right, so let's take a look at it. What do you get over here? 1/2 36 t squared plus 9. Take away 1 from the power, that would make it minus 1/2. I'll clean that up later. Times derivative of the inside, which is going to be what? That's going to be 2 times 36, which is 72t. Derivative of 9 is 0. I'm going to simplify this. And, 2 goes into 72, 36 times. And that root problem's on the bottom now. I'll write this over here. That's 36 t squared plus 9. I'll put a box on this. All right, let's look at the answer. And ooh, they did something spiffy there. So what happens with a lot of students, they look at the answer, oh man, that must be wrong. Well, I need to struggle toward that answer now. And I'm going to say maybe what they appeared to do was factor the bottom. And what comes out from the bottom? Actually, the root of 9. And what would you be left off with? Well, 9 times what? Give you 36. That would be 4t squared plus 1. And this simplifies. The root of 9 is 3, and 3 goes to 36 12 times. So 12t over the root of 4t squared plus 1. Again, I would like to match the answer keys, and that's your goal too, to match the answer keys. Is this answer acceptable? Of course it is. Some teachers might penalize that though. They say you didn't simplify it fully. Now granted, it's an endless game of simplifications. You may say to yourself, I'm exhausted. Try to aim for getting the derivative, all right? Let's take a look at number 5, relatively simple. I'm looking at it, and what am I gonna do? Well, it's basically written to work. So minus 5 halves times x squared plus 5x plus 1. I got to take 1 from that power. That's going to be minus 7 halves. Yes, you need to know arithmetic. Times the derivative of the inside, which is 2x plus 5. I'm going to simplify this guy. And as I do that, again, you might say it's crazy to simplify. I want to just leave it there and put a box on it. Let's see what we get. We get on the bottom, we get, let's see, we get 2. And then I get x squared plus 5x plus 1 to the minus 7 halves. I'm sorry, to 7 halves. On top, what do you get? Minus 5 times 2x plus 5. I guess that's not a bad answer, but I still want to look at the key. And I noticed in the key they did something. What did they do? Well, the top's really the same. So I got that part. What are they at the bottom? 7 halves is actually 3 1/2. So what did they do? They rewrote it. And I'll write this as minus 5 times 2x plus 5. And on bottom, what do I get? Well, I get 2. And remember, I said it's 3 1/2. So it's going to be x squared plus 5 plus 1, 3. And there's a half a factor left over, which is going to be the root of x squared plus 5x plus 1. Oops. And I do see that. I see that answer over here. All right. Again, it's carefully look at the answers to make sure that you can match their answers. Is this answer acceptable? Of course it is, but you're going to have to start learning that you don't need to match some kind of standard way of writing things down. By the way, you could continue to simplify that, but the bottom line is it really, you might say yourself, kind of go further and further and further. You can. If you have a textbook and you're looking at a textbook, you might be surprised how far they go in simplification sometimes. All right. As we move forward in the course, though, we want to be able to simplify. All right, let's keep going. Let's go to problem number 6, relatively simple. And I'm just going to rewrite it a little tiny bit. And this is going to be d dx. And I'm going to write it as, let's see, it looks like I'm going to want to take the derivative of, well, this is going to be x plus 2 to the 1/2 power minus 1, the whole thing raised to the 7 halves. All right, let's write the derivative down. So it's going to be 7 halves, outermost function. And then what do I get on the inside? Well, I get x plus 2 to the 1/2 power minus 1. And that's going to be raised to the, well, 7 halves minus 1 would be, let's see, that'd be 2 at 5 halves with it over there. Now I got to go to the inside, take its derivative. And what would you get over there? Well, 1/2. And then you're going to get x plus 2. I take 1 from 1/2, that would be minus 1/2, and the derivative of the inside is going to be 1. All right. I want to simplify that tiny little bit, not too much. And what would I get over here? Well, I get a 4 in the bottom, and that x plus 2 to the minus 1/2 is just a root of x plus 2 on the bottom. X plus 2 on the bottom. What do you get on top? We get a 7, and then you get this thing over here, which is the square root of x plus 2 minus 1, all raised to the 5 halves power. Now, granted, in the tradition of the last problem, I hope you remember that you could rewrite this a little bit differently. Whoops, I did a mistake there. X plus 2. And you could write this as 7. 5 halves is 4 1/2. So you could write this as, I'm, I'm sorry, 2.5. So it's going to be x plus 2 minus 1 squared, and then it's going to be x plus 2 minus 1 to the half power. Now, granted, I don't think that adds much to the problem, but you could rewrite that down. I'm going to say this looks like a better answer to me. Let's look at the key and see what they have. Now, let's see if we got the right answer. 7, 4. Yep, everything's looking good. I want to warn you against rewriting on exams, by the way, because what happens to students sometimes is they try to be spiffy with their simplifications and they don't have the necessary algebra skills. And then they get penalized for putting down a wrong answer. So if you can put down a simple answer that may not be completely simplified, that's better than putting a wrong answer down that's been simplified. All right. So let's take a look at the next question. Relatively simple. I'll write it down for you. And as I do these things over here, outermost functions is 7th power. It's going to be 7 times x plus 6 over x minus 6 to the 6th power. Now I got to use the quotient rule. What's the quotient rule? X minus 6 squared on bottom, x minus 6, derivative top is 1, minus the top, which is x plus 6, times the bottom, which is 1. If that's your answer, you know what? Good for you. That's a correct answer. All right, let me just get my red pen out to say it's not equal to that over there. I got to be honest with you. I would like to simplify it if I can. All right, and let me see if I can do that. As I do that, every you might say stuff that you're wasting your time simplifying. At some point, you're going to have to simplify. So I'm going to simplify this guy. And what do I notice? I notice on the bottom, I have x minus 6 down 6, 2 times, 8 times. On top, what do I have? I have 7 times x plus 6 to the 6th times, I'm going to circle this guy over here, and I want to simplify that. What would that give you? X minus 6 minus x minus 6, which would be minus 12. All right, I'll put that down for you. Oops, get back to black. I'm going to simplify that a tiny little bit. And what do you get? X minus 6 to the 8th power. And 7 times minus 12. Let me get my ratio. It doesn't look like an 8, does it? Okay. 7 times 12. I know it's a negative number. That's going to be 70 and 14, 84. And x plus 6 to the 6th power. Put a box in that. Get my red ink out. Look at this. Look at this. And I feel pretty good about that. All right. Let's do the next one. And again, this is, find a derivative. And I just want to rewrite a little tiny bit. And this is going to be cosine of 2 theta all cubed. All right. So what do we want? We want y prime. And what's y prime in this case over here? It's actually dy d theta. Let's write this down. It's going to be 3 cosine 2 theta to the 2nd power times the derivative of the inside. Well, that's going to be cosine. It's nested. So it's going to be minus sine of 2 theta. And I got to go to the inside of that now. And the derivative of 2 theta is going to be 2. Let's write this a little differently. I kind of commuting things around, and 2 and a 3 goes together. I got a minus there. So minus 6 cosine squared 2 theta times sine 2 theta. I'll put a box in that. Let's look at the answer key, see if we have that. And I'm looking at it, I'll look at it carefully. Yeah, we did good. Let's go to number 9. And number 9 is, well, we have to do the tangent, right? So what do they want? Well, they want dy d theta, all right? And it's going to be an easier one, at least I believe so. Dy d theta. Again, some students write down y prime. As long as you know y prime in this case means dy d theta, that's fine. So what do you get? Secant squared, that's derivative of tangent. 4 theta squared minus 8 theta. And now I got to go to the inside. And what's its derivative? 8 theta, right? Minus 8. All right. Well, I'm gonna commute things around and factor it a little bit. I'm going to say 8 times theta minus 1 times the secant squared for theta squared minus 8 theta. I'll put a box in this, and then I'll look at my answer key. So I'm looking at this, and I'm looking at their answer, and yeah, it looks good. All right. Number 10, this is dy dx. It's an exponential function. So I want dy dx, fairly simple. But when I say it's simple, if you know the chain rule, it's simple. What do you get over here? Well, the derivative of e is going to be e to its power, which is 2x to the 12th times, now I got a derivative of its power, which is going to be what is going to be 24 x to the 11th power. All right. I'm going to rewrite this a little bit differently as 24 x to the 11th e to the 2x 12th. Put a box in this. Want to look at the answer? This is the answer they're providing to me. And I want to see if I got it right. 24x11. Yep, not bad. Let's go to number 11. Number 11, it's another derivative. And what do they want? They want y prime. And y prime in this case is actually dy dt. Fairly simple. It's e to the power times the derivative of that power. The derivative of that power is going to be minus, I'll write this over here, 12t. Let me write that down for you. Minus 12t e to the 1 minus 6t squared. I'll put a box in it indicating its finality for me, but I don't know, maybe I got it wrong. Let's take a look, and I'm seeing it, and that's good news. Let's go to number 12 now, all right? So number 12, well, next page, number 12. Wow, you know what? I think I'm ready to do it without doing a bunch of rewriting. And the reason for that is I know these are half powers, and I've been differentiating the square root function, and what's that going to be? It's really 1 over twice the root. And what's the root going to be? Cosine 3x plus sine. You know what? I got to get my eraser because I can't fit it in there, can I? And let's just say it's going to be sine of x7 times, I got to do it to the inside now. And it could be tough. Let's take a look at it. So the derivative of cosine is minus sine 3x times derivative of the inside, which is 3. Then I got to do the next guy, which can be plus cosine of x7 times 7x to the 6th. All right, I want to rewrite that guy because it just doesn't look right to me. And I'll write this down as the bottom, which is 2. We'll look at the key later. Cosine 3x plus sine x7. And what goes on top? I'd say 7x6 cosine, that's cosine, x7 minus 3 sine 3x. If you like, you can put parentheses in these things over here. And some people prefer to do that. Let's look at the answer and see if we got it right. I don't know, maybe we got it wrong. So this is their answer. And this is my answer. Is it the same answer? Let's take a look. 7x6 cosine x7 minus 3 sine 3x. On bottom, I see 2 times the root. What's inside the root? The radicand, cosine 3x. Yeah, we did good. All right. So let's go 13. And again, a little more complicated, but I really think that this one probably should be rewritten initially. All right. So let me put this one down for you. And what I want is I want to take the derivative of the function that follows with respect to z. And the function that follows actually is a power function. And don't be discouraged if you have trouble with this. A lot of students do. I'm going to keep moving left to right now. So what do I get? I get 1/2. And then I write this over here. 3z plus 2, 3z minus 2 to the minus 1/2 power times the derivative of the inside. Whoops. 3z minus 2 squared 3z minus 2 times the derivative top, which is 3, minus the top, 3z plus 2 times the bottom, which is 3. I got to be honest with you, I would actually accept this as an answer. Be aware, though, that most people would not accept that as an answer, right? Most teachers say that's not fully simplified. They'd say, yeah, you got the derivative right, but you didn't simplify. Your goal is to simplify things. If you talk in a tone where everything is super complicated, people will stop talking to you. So let's go through this. And the first thing I do is just try to write down a simple form of this. So the first thing I see a negative power, what does that mean to me? 3z minus 2, 3z plus 2 to the 1/2 power. Let's keep going. What goes on the bottom here? Well, 3z minus 2 squared. What goes on top? Well, let me write this down for you. It's 9z minus 6 minus 9z, right? Minus 6. What does that give me? Minus 12. All right. Now, I think that's simpler, and I'd be willing to accept that one. I want to keep writing it, though. And what do I notice over here? Well, this is going to be minus 6 now. That's the number part of it. All right. Now, I'm looking at the powers, and I want to kind of write it down for you. I'm definitely seeing the square root of 3z plus 2 on the bottom. Now, I notice there's the factor of 3z minus 2 on the bottom and a factor of 3z minus 2 on top. Now, I know the rules of exponents, so I'm going to write this down as 3z minus 2, well, to a power. What power? Well, it's going to be, let's see, 4 halves minus 1/2 is 3 halves. All right. By the way, someone says, are you going to go further? I am. I'm on a run. Minus 6. And what do you get over here? The root of 3z plus 2 times, well, 3 halves is 1/2, right? So it's the 3z minus 2 times 1 factor, 3z minus 2. All right. Let's keep going. I know it seems like a lot of work. We're trying to encourage the work. What's the root going to be? Well, it's going to be 9z squared minus 4. What do you get over here? 3z minus 2. I got to warn you, though, on exams, especially with me, I wouldn't be doing a bunch of extra work. I'd be going for the minimalist answer over here. I'd be going for this one over here is what I'd be going for. Let me see if that's written down for you, though. I want to see if that's written down. And I notice that that's written over there. So make sure that you're looking at what I've got on the thing and make sure it's the same thing. I'm actually looking at it too, and I'm seeing it. I'm going term by term by term by term. Yeah. But what did they do? Well, they did some other work on it. And someone says, I don't like all that work you've done, and you still didn't match the answer that you're given over here. Well, you know what? I think probably I'm getting close to it. And I don't know, let's take a look at it. And I'm gonna try to get their answer now. I'll go through it with you. Looks like they rationalized the bottom. You're going to learn a lot by trying to match someone else's language in mathematics. And what do you get on top? Minus 6, the root of 9z squared minus 4. What do you get in bottom? We get 9z squared minus 4 times 3z minus 2. I'm still not matching it. So what do you get over here? Minus 6, the root of 9z squared minus 4. And 9z squared minus 4 factors into 3z minus 2, 3z plus 2. And what do you get in the end? 3z minus 2. And this further simplifies. I know it's a lot of work. 9z squared minus 4 over 3z minus 2 squared times 3z plus 2. And I found that remarkable if someone did that in the exam. But you know what? You have to start realizing there's a lot of remarkable people in the world. They do a lot of work. All right. And hopefully they'll be recognized for all that work they've done. Did I get the same answer? Let's see, 3z plus 2. Wow, miracle. I got it. All right. So that's number 13. And I think there's some more problems. Yeah, 14 and 15. Relatively simple. Let's just go through it one at a time. And I'm going to say they're relatively simple problems. What do you get? Because we're getting better with the chain rule. It's going to be 6 times 2e to the 5x plus 3e to the minus 2x raised to the power 5. All right, let's keep going. In this side now, what do you get? Well, I'm looking at it. Certainly e to the 5x times 5. So it's going to be 10 e to the 5x. We'll look at the key later. What do you get next? We'll get minus. That's going to be e to the minus 2x times minus 2. So minus 6. e to the minus 2x. All right. So I'm going to say that's a good looking answer. Of course, if you look at that, it's right over here. And make sure I got that right. I did. Looks like they put another answer down. And my question is, what did they do? Well, I guess they didn't do much with that, did they? No, but you could do something else with it because you could factor it and stuff. No, that's it. We're done. All right, let's go to the next one. What's this guy over here? Find the derivative. Well, most people write down y prime. What's y prime here? dy dx. Fairly simple to do. It's going to be e to the power. What's the power? 5x squared plus 5x plus 4 squared. Now you got to take the derivative of the power. What's that going to be? 2. I'll clean this up later. 5x squared plus 5x plus 4 to the first power. I'm not going to put the number 1 down, by the way, times derivative of the inside, which is going to be 10x plus 5. All right, I'm going to simplify a little tiny bit. And I'd like to put the polynomials up front, the numbers up front. I notice a 5 comes out. I'm going to factor out a 5 from that. 5 and a 2 gives me a 10. And then you'd get what? You'd get 2x plus 1, 5x squared plus 5x plus 4, and then you'd get e to the power 5x squared plus 5x plus 4 squared. I'm going to commit to that answer. Oh yeah, mistakes can happen, but let's take a look what they've got over here and see if they got the same answer. And I'm looking at it. I see the 10, I see the 2x plus 1, I see the 5x squared plus 5x plus 4, and I see e raised to the power. All right, relatively simple once you master the chain rule. All right, chain rule is an important rule to be using, and you want to master that rule. It takes practice and time, though. Thank you.